Blockchain Skills for Educational Professionals, or in other words BLISS, aims to improve skills and competencies of the ICT professionals in the field of blockchain application and development. The BLISS project partners develop and make available educational resources and materials that address existing occupational needs, infrastructures, and contents, and introduce to you a vocational open online course consisting of 4 learning units, including Blockchain Essentials for ICT Professionals, Blockchain Platforms, Communicating the Business Merits, Challenges, and Implications of Blockchain Technology, and Practical Design and Development of Blockchain Applications. In this video, we are going to introduce Learning Unit 4, which explains the practical design and development of blockchain applications. The content of this learning unit is developed by the Institute of Computer Science of the University of Tartu in Estonia. After completing the first part of this unit, you will be able to collect and formalize functional and non-functional requirements of a given scenario, to explain and communicate the design and development of use case at different stage to potential users and stakeholders, and to develop and apply appropriate software architectures. We will base our discussion on the parking decentralized app. The idea is to use the parking spots that are free but not available for renting. For instance, supermarkets have a large parking lot that, after closing hours, are unused. Likewise, during opening hours, there are times of the day when customers are not visiting supermarkets that frequently. So the parking lot stands empty. This is a resource that supermarkets have but are not used. But they may wish to capitalize and get a bit of more revenue. Likewise, many parking spots that belong to apartments or houses stand empty during the day because the owner is away with the car on his work. So there is a parking spot being unused that could be rented and generate additional revenues for the owner of the parking spot. At the same time, there are people who need a parking spot. Somebody might come to visit a friend in the housing area close to the supermarket. But the price of parking in that area is quite high, or it might be difficult to find a spot. The supermarket parking lot might be an option, but they cannot park there because it's prohibited. So they would like to rent this parking spot. Or if people are visiting somebody and going to some part of the city where the houses are empty during the day, they could rent those spots for a certain number of hours. So the case is that we have supermarkets and we have households that own a parking spot, but they are not using these to generate revenues. At the same time, we have individuals who need parking spots. So the supermarkets can offer their parking spots, so can the households. And that can be matched by the people who need a parking spot for a certain number of hours. So this is basically connecting those who have parking spots with those who need a parking spot for the benefit of both. We are going to illustrate how to build this application on the blockchain. We speculate that the blockchain enables a lower transaction cost. If it was a traditional centralized solution, the broker fee might be 20%. But with blockchain, the costs are lower. Furthermore, because it is a trusted system here, we have to ensure that the funds which are transferred from those who rent to those who own the parking spots. We will use this aspect of the blockchain to create trust in a system, making sure that the transfer of funds is happening properly. In so doing, we will focus on the high-level requirements. The first one concentrates on registering the parking spot and specifying the availability. The second is about searching and reserving the parking spot. Third one is to start and end the parking session, which should be performed according to reservations. We will also look at the example of extending the parking session. In this learning unit, we illustrate how to approach analysis of the data, state and behavioral requirements. Further, we will describe when and why certain blockchain technology should be selected. For example, in the case of the parking DApp, we need to track the states of the parking spots. We deal with multiple parties, and our system is this intermediate. In addition, we are able to identify all the parking spot owners. This means that the hyperledger, which is permission blockchain, should be selected for the system implementation. Next, in this learning unit, we will explore design and implementation capabilities using the Hyperledger Fabric technology. After completing this learning unit, you will be able to define the chain code, namely the smart contract as it is called in Hyperledger Fabric. It is responsible for defining the data structures that will hold the information about the digital assets and can be used to implement the business logic. Secondly, we will discuss the state database, which is manipulated by means of the chain code. Thirdly, the bridging to the off-chain will be described in terms of both interactions during query of transactions and interaction during commanding transactions. Finally, we will discuss how to initialize the authentication services and connect such services with the application.